All right, so welcome back. In the last video, we were talking about the period and the amplitude of the sine function. Now we're going to do the same thing for the cosine function. I've already written in the period, which is the same from 0 to 2 pi, and the amplitude, in this case from 0 up to 1. It gets up to 1 here. We can see there's a little difference. The sine function started at 0 and went up and down at 0 here. But here, it starts at 1, goes down, comes back up to 1. And if we look at the unit circle, we can see that cosine is the x, starts at 1, goes to 0, goes down to -1, back to 0, back to 1. So that's kind of shifted over. And there's an interesting thing here because the cosine function, therefore, is symmetrical about the y-axis. Can you see that? All right, so now what I'm going to do is let's look again at the same things that we were looking at last time. So what if I say y equals cosine of x? That's the thing that we see here. And what if we put y equals minus the cosine of x? Well, there again, I would expect the thing to flip upside down, right? So if I look at that, let me do that in yellow. No, let me do it in purple. So I would expect it to go down here and up here and then down here. So I'd expect it to go something like this. So minus the cosine of x. But what about if we go negative? Y equals cosine of negative x. Well, now when I'm looking at this, if I take, for example, this point here, I take this point here, instead of giving cosine pi over 2, I would give it negative pi over 2, which is, because it's symmetrical in the y-axis, it would be the same. So here's a strange answer, isn't it? Cosine of negative x is not going to be the same in when we were talking about sine. These two were the same. In this case, it's not going to be that. Cosine is going to be the cosine of negative x is going to be the same as that one. All right, and then if we think about it, we would expect that the other two things that we fiddled with, y equals 2 cosine of x, similarly to sine, I would expect that to fiddle around with the amplitude, right? And y equals cosine of 2x, I would expect that to scrunch up the period. Let's go and have a look in GeoGebra and see if that's the case. So here I've got a cosine function, and we see it starts at 1. I'll move it over a bit so we can see one whole period on half a period on. Okay. So it starts at 1, it comes back to 1 at 2 pi. And if I do negative cosine of x, I would expect it to flip in the x-axis. There we go. And if I go cosine of negative x, I expect it to be the same, not as in sine, these two are the same, but now I expect it to be the same as the cosine. There it is, the same as the cosine itself. So this one and this one are the same when we're talking about cosine. And now let's go and look at what happened if we fiddle with the amplitude. If I make it 2, then everywhere it increases the value by 2. And if I fiddle with the slider, we can see that that's exactly like we had before. Now it's going negative, right? It's down to -3, coming back to 0. At 0, it'll be flat. And then it'll go up to as far as +3, up to +3. There it is. Okay. And if we fiddle with the period here, we're going to scrunch it down, put 2 periods into the space of 1. And similarly with the slider, I'm going to 3, and then it goes to 0 and goes the other way. But notice that now on both sides, whether it's -3 or +3, it's exactly the same because it's flipping around here, whereas sine was flipping around here. All right, that's it. Thanks for watching.